All right, welcome to another episode of Science with Surback. Today what we look at here is the Unit 2 free response questions for the AP Chemistry exam. So this deals here with Lewis structures and some properties that go along with the Lewis structures. So we'll go ahead and get underway with question number 1A. First off, the question deals with N2 nitrogen and N2H4, and so we're going to be looking at both of those structures and answering some questions on those. So question 1A says, draw the electron dot diagram of N2. So remember, the first thing with electron dot diagrams here is that we want to identify how many electrons we have to deal with. Well, each nitrogen has 5 valence electrons, and in a molecule of N2, we have 2 of those nitrogen molecules or nitrogen atoms. And so we have 10 valence electrons to work with. Well, how we set up this structure is we're going to put these ends spaced out from one another. And then if you remember from notes, we actually did this. N2 actually needs a triple bond, and remember, each of these lines represents 2 valence electrons. Now, to complete the octet, we're going to need to have electrons on the outside. And just to double check ourselves, we needed 10 valence electrons, and if we count these up by 2s, we have 2, 4, 6, 8, 10 valence electrons. So this is our structure of N2. Now what we have here is this. It says, based on the Lewis structure or the electron dot diagram that you drew above, is the nitrogen molecule polar? And so I'm going to grab another piece of paper here. Again, for question 1B, it says, hey, is N2 polar? So to answer this here, number one, N2 is not polar. Okay, so why is N2 not polar? Well, number one, there is three bonding and 1 non-bonding sets of electrons. So we could say because there is 3 bonding we could also say, along with the 3 bonding and 1 lone pairs of electrons, that the molecular shape is linear. So you could say linear shape. And then you could also say that a bond, the bond in nitrogen here, is a nonpolar covalent bond. So all 3 of these reasons are why N2 is not polar, okay? So if we flip over here to our next set of questions, we're going to shift back over to the sheet here, and it talks about the graph here that corresponds to the distance to the bond length of the N2 molecule, and we want to place an X on that particular distance. So you can see this particular chart here, this graph here, shows the potential energy and what we call the internuclear distance, or how close atoms are in a bond. So remember, a triple bond equals the shortest bond length or shortest bond distance. So on this here, where we're going to have our X is going to be right here, where really, and I could have moved this over, probably best to be down here closer to the right. But again, because our nitrogen has the most energy, the shortest bond length, it's going to be drawn here right where I place that X. And we could go one step further. The question doesn't ask this, but this is the most stable distance. And again, think triple bonds are really strong. There's 3 covalent bonds shared between 2 atoms. All right, so now what we have here is this. It says on the graph, which shows the potential energy curve of 2 nitrogen atoms, carefully sketch a curve that corresponds to the potential energy of 2 oxygen atoms versus the distance between their nuclei. So just as a quick reminder, remember O2 has a double bond between those 2 atoms. And so our Lewis structure would look like this, just as a reminder. And the big takeaway here for oxygen atoms is that they have that double bond. So on this graph, we are going to make a very similar type of drawing, except it's going to be altered to reflect this double bond here of oxygen. Okay, so when we do this, we have to think about a double bond. Number one, a double bond has a greater length or a greater distance than the triple bond. So what we have to think about here is that ending point is going to be a little bit further out to the right. And what happens here is this. The potential energy is going to be less because, again, we only have 2 covalent bonds compared to 3. So our line here for oxygen, and since I'm writing in a black pen, I'm going to put O2. It's going to have less potential energy, but the distance is going to be further. So I drew that line out further. And this shows 2 things. One, the value of the curve here is lower because the energy of the double bond is lower than that of the nitrogen triple bond, but the distance is greater. So double bond here, less energy, less potential energy, and the bond distance compared to that of a triple bond or nitrogen is less. All right, so we move on to part 1E. So it says a sample of N2H4 has a mass of 25 grams. Identify the numerical quantity that is needed to convert the number of grams of N2H4 to the number of moles. And it says you do not need to do the actual calculation. So for this here, I'm going to shift back over to our sheet of paper, but for 1E here on this problem, number one, what we're looking for is the molar mass. So we're dealing with N2H4, and for this we can turn to the periodic table, but what you'll find here for nitrogen is that it has an atomic mass unit of 14.01 grams. We multiply that by how many nitrogens we have, and we end up with 28.02 grams per mole. Then for the hydrogen, we would have a molar mass of 1.01 grams times 4, and that gives us a mass of 4.04 grams per mole. Now, when we go to add these together, we would end up with 32.0 grams per mole. Now, what we would do here with this value or this number is we would do this. We would put 25 grams of N2H4, And then remember, diagonal units cancel out. So we would put that molar mass there of 32.06 grams to every 1 mole of N2H4. And again, units are important here so we can see what is happening. Now the problem says you do not need to do actual calculations, but just to show or just to emphasize here how many moles that would be, we'll do 25 divided by 32.06, and you end up with 0.78 moles. And again, that is not required for points on this problem because the question said you do not need to show that particular calculation. But just to identify that you do have that molar mass and you can calculate that, you have that calculation there. All right, so we'll shift back here and we are actually going to look at a few things here. Part F, 1F of this particular problem says the electron dot diagram of N2H4 is shown below. I'll flip my page here. And there it is. Okay, so this problem here, problem F, letter I, says based on the Lewis electron dot diagram of N2 and N2H4, compare the length of the nitrogen to nitrogen bond in N2 with the length of the nitrogen to nitrogen bond in N2H4. So a couple of things here. This right here is a single covalent bond. Okay, so keep that in mind as we shift back to the sheet of paper. And you can keep that handy as you answer this question. But this here is 1F and letter I. And so how we answer this is this. N2 has a shorter bond length than N2H4. And you could even go one step further and say N2 has a triple covalent bond and H4 has a single covalent bond between your nitrogens. So remember, as you add more covalent bonds, your bond becomes shorter and shorter. Okay, so that is how we would answer part I of that particular question. Now, again, to get credit for this problem, you don't need to add that there is a triple and a single covalent bond and triple is shorter. You just need to say, hey, N2 is shorter than N2H4 in terms of the nitrogen bonds. But that's to give you a little background, a little reasoning why that is. So I'm going to shift back here to part 2, or II here, and it says based on the electron dot diagrams of N2 and N2H4, compare the strength of the nitrogen to that of N2 in N2H4. So the strength, again, I'm going to emphasize this before we head out. This right here is a single covalent bond. N2 had a triple covalent bond. So in part 2 of this particular question, the N2 has a stronger nitrogen bond than into H4. Okay? And that is because, again, you don't need to write this down, but triple bonds are the strongest covalent bonds. And so a single bond would be the weakest covalent bond. Okay, so we've answered here the parts 1, 2, and 3. And now we turn to the hybridization. So I'm going to flip back towards the sheet, and we are going to get to the hybridization of our nitrogen atoms into H4. So I am just going to look at one particular nitrogen atom at a time. And so I'm just going to identify this particular nitrogen atom. So with hybridization, it is the number of bonding pairs plus lone pairs. So right now, this has 1, 2, 3 bonding pairs plus 4 from your lone pairs. So we need 4 hybrid orbitals. And I'm just going to note this down here as we need 4 hybrid orbitals. Well, remember, with 4 hybrid orbitals, the hybridization here that we would get for nitrogen into H4, into H4 would be sp3. What that tells us is it uses 1 s orbital and 3 p orbitals. Now, that would be the same for this nitrogen because they're identical in what is bonded to them. Again, it is the number of bonded plus non-bonded pairs to get to your hybrid orbitals that you need. All right, so that completes this answer to Unit 2 questions. Hope you have enjoyed this particular video.